Good afternoon, everyone. My name is Aadit Shrestha, and today I'll be talking about DDoS attack. So let's begin. Let's say we have an e-commerce website. Our website is generating revenue, everything's going great. Our customers are buying stuffs, our sales going really good, costs are down, our charts are going up, everything's just rainbows and sunshine. But one day, when we check our charts, we find that customers aren't buying anything anymore. Then the next thing we realize is our URL just stops working. First, we just brush it off saying, okay, it might be just an internet issue. But as time goes on, we realize, okay, only our URL is not working. Now that's when the panic starts to sink in. Now, this is probably because we've just been attacked by some hacker, and it's highly probable that this is a DDoS attack. A DDoS attack, which stands for Distributed Denial of Service, it's a malicious cyber attack which aims to make the servers, or networks, or services of a website completely down, shuts it down by sending fake traffics. Now, this is mostly done by using bots. So what are bots? A hacker uses their malicious software to sense it on different computers and hardware, controlling it. And these devices, each of these infected hardwares or devices are known as bots. Now each of these bots network with other bots and create a disruptive network known as the botnet. Now this botnet simply actually has a lot of function. It is capable to do multiple things, but it has the same objective: to make the web resources available to actually deny the web resources available to customers by shutting down the website. So there are generally three types of DDoS attack: application layer attack, protocol attacks, and volumetric attacks. So let's move on to the first one, the application layer attacks. So this attack actually targets and disrupts a specific app, not an entire network. So let's take an example. Normally, when a client sends an HTTP request, the server just takes that request and collects all the information related to that page, packages it, and sends it back to the client, whoever asked for it. Now, all of this fetching and packaging is done in the application layer. So in this attack, what happens is the bots send HTTP request asking the same resource repeatedly, and over time, it overwhelms the websites or the servers and crashing it. Now, this is challenging to prevent because it's difficult to distinguish between a legitimate and malicious HTTP request. So moving on, we have the second attack, which is known as the protocol attacks. This attack is also known as a network layer attack. Now, this is done by exploiting the protocols. The most common is the sync protocol attack. So what happens in this is, normally, when two devices start to create a secure connection between them, we use TCP handshake protocol for the connection. In TCP handshake, the first client sends a sync packet to the server. The server responds to it by sending a sync and acknowledgement packet, and the client again sends back an acknowledgement packet. Now, the attacker exploits this by using spoofed sync packet. It sends a lot of spoofed sync packet to the server. And when the server just waits, when it sends for sync acknowledgement packet and waits for an acknowledgement from the client who asked for it, they just don't reply. They just keep on sending more and more sync packet. So the server just keeps on waiting for an acknowledgement, but it still gets a lot of more sync packets, and again, it crashes the server. So this is how protocol attack works. And finally, we have a volumetric attack. Now, this attack consumes the target's bandwidth with false data request. The most common type of a volumetric attack is the DNS amplification attack. What happens in here is the attacker takes the spoofed IP address of the target, uses that IP address, and sends it to the DNS server requesting a lot of things. So it just keeps on sending a lot of requests to the DNS server, and the DNS server takes all that requests and sends back response. Now, when it sends back the response, it does not send it to the target. It sends it to the spoofed IP address. It does not send it to the hacker, but rather to the spoofed IP address of the target. So the target's website or server is completely overwhelmed by the DNS server, and it again causes the server of the target to crash. Now, most of these, actually all volumetric attacks rely on botnets, and these are the most common type of DDoS attack. So what are the usual DDoS symptoms? The first one is the large amount of traffic coming from clients with the similar characteristics. It's like their IP or IP range, their location, browser type, version, etc. The other one is an exponential rise in traffic at a single server. The other one is a server starts repeatedly crashing for no reason. And finally, your website is just taking too long to respond to requests. So what can we do when you find these symptoms in your websites? So to respond to these DDoS attacks, the first one is the black hole filtering. In this, we just go through the incoming traffic and we determine a limitation criterion. We use that criteria to check the traffic, and based on that, we just send them to a black hole. It simply means we just drop all the traffic outside. So the next one is casting, in which we distribute the traffic across multiple servers, increasing our capacity and decreasing the chances of the individual service getting overwhelmed. And finally, IP blocking. So if you notice unexpected high traffic from the same range of IP address, we just simply block it. So it is, even if you know how to respond to these attacks, it's actually really overwhelming when you're facing it. So it's better to prevent such attacks. And some of the preventive measures are a real-time packet analysis, in which we analyze the packets based on the rules we've set and discard the potentially malicious ones. The second one is DDoS, which stands for DDoS Defense System, in which we detect legitimate looking content with malicious intent, and it protects against the protocol and volumetric attacks. The third one is a web application firewall, which is really good to prevent from application layer attacks. In this, we just we use this firewall to filter the incoming requests based on the rules we've set. And finally, rate limiting, in which we limit the number of requests a server can entertain over a certain period of time. Thank you.